You'll notice the difference here is that we have a 3x and a 7 and a 20. And there is no way for us to make 7 and 20 the same base. So everything up until this point, we've had like 2 and 32. Oh, we can make those like bases, and then we can just set our exponents equal to each other, and we're good to go. Yeah. But that is not the case here. All right. Here we have a base 7 and 20. And there's nothing I can take 20 and 7 to make them the same base. And so what I'm going to do is I'm actually going to take the log of both sides. All right. Just like any solving equation, whatever you do to one side, you can do to the other, and you keep the equation the same. And so I'm going to say log of 7 to the 3x equals log of 20. All right. And then this is how this helps me, because I have properties of logarithms that will now get that 3x out of the exponent position. Why can I move the 3x out of the exponent position? What property tells me I can do that?
Power.
Yeah, my power property. The property that tells me I can take this guy and move him in front. So I now have 3x times log 7 equals log 20. And now I'm literally just solving for x. Log of a number is a number. It's an actual number. So log 7 is a number. It's 10 to what power equals 7, all right? Log is base 10, okay? And so I can divide both sides by the 3 log 7. Those are just numbers. Divide the left side by that, divide the right side by that. And so on the left-hand side, I'm left with just the x because the 3 and the log 7's cancel. And in my calculator, I can put log 20 divided by 3 times log 7. And when you round to 4 digits, which is what logs are typically rounded to, you get 0.5132. So for this one, I take the log of both sides, which gives me log of 3 to the x plus 4 equals log of 101. I move the x plus 4 into the exponent, from the exponent to the coefficient. You'll notice that I put parentheses around this because this is a group. So I have x plus 4 times log 3 equals log of 101. If I'm solving for x, I'm going to divide by this log 3. So I get x plus 4 equals log of 101 over log 3, subtract your 4. You have to do it in this order in your calculator. You have to do the log of 101 divided by the log 3, close that parentheses after the 3, and then subtract the 4 after your answer. So in your calculators, you have a log and you have an ln, all right? Your log is base 10. If you have another base, your calculator is just going to do base 10, meaning it's going to say 10 to what power equals whatever. This formula right here, you can convert any base using your base 10s, all right? And so the formula is log base b of m equals log base c, whatever your new base is, over log base c of b. They give us an example using it on the next page, but I actually want to show you a quick one really quickly before we do this next one, because I want to tell you exactly what you're solving for. So let's say I had something like log base 3 of 27. That's easy. 3 to what power equals 27? I don't even need a calculator for that, right? But then if I had something like log base 3 of 30, it's not easy. I don't have any idea because it doesn't go straight in. So what it's saying is on your calculator, you can use just your log, which is your base 10 of 30, divided by log, which is your base 10 of 3. So if you did this with this guy right here, log of 27 divided by log of 3, you should get 3. All right? We already know that 3 to the third power is 27. But when you don't know it, you can still use this change of base. All right? So your calculator now can help you do any base to any power, pretty much is what you're looking for. All right?
Wait, what?
Formula. So it says use the change of base formula to evaluate log base 3 of 15. Then convert log base 3 of 15 to a log base 2. All right? So the first thing we're going to do is we are going to evaluate. So log base 3 of 15, we're going to evaluate that using our base 10. That's log of 15 divided by log of 3. And if I round that, I should get 2.465. Meaning 3 to the 2.465 equals 15. That's what that means, okay? So what I just figured out is 3 to the 2.465 should equal 15, okay? That's what I've just solved for. Now they want me to convert this. So what they want is they want me to take log base 3 of 15 and convert it to a base 2. So they're saying 2 to a power and 3 to the same power should equal 15. All right? So I've already solved for this piece of it, right? I already solved for this. That equals 2.465. 2.465. So I'm going to say 2.465 equals log base 2 of what number? So the best way to do this is to rewrite this as an exponent. They show it differently. They multiply, they do it with change of base. You can do it a couple ways. You could actually just do 2 to the power. That's what I would do here. I'll show you the way they did it, and then I'll show you the way I would do it. So we'll look at it both ways. The way they did it is they rewrote this side with the change of base formula. So they said 2.465 equals log of x divided by log of 2. And then they multiplied both sides by log of 2. All right? And so if you put that in your calculator, you get approximately 0.7420. Make sense? So I just did it that way. There's another way you can actually do this. So if I were to take this right here, how else could I do this particular one? How do I write that in exponential form? How would I rewrite this in exponential form? It's in log form. This is my base, right? 2. This is my power, yes? 2.465. And this is what it equals. So in your calculators, you could actually just do 2 to the 2.465.
So let's haven't gotten to the answer yet.
Right, because here's what's happened. We solved for log of x. So we solved for 10 to the power. So you have to actually do 10 10 to the 0.7. You still have to use this method to solve for x. And I think it's easier just to go to that method straight from here. So 2 to that power and 10 to the 0.7420 should equal the same number, which is 5.521.
And that's our answer?
Mm-hmm. So I would just, once you get it to this point right here, I would rewrite it in exponential, and then I would just put it in my calculator. Because it's faster than doing all of this down here. All of this gets confusing.
So just go straight to the.
Right. So use change of base to solve this one. Then set it equal to the new base that you want, that it told you. And then go straight to exponential form and put it into your calculator.
Oh, that's.
So much easier than the method they showed. Okay? Base. All right, so remember I said that logs and exponents are inverses of each other. And so a log of the same base as the exponent of the same base will cancel each other out. So if I have this equation here, 2 to the 3x equals 172, there's two ways to do it. The first way is the first example, where I did the log of both sides, and then I pulled my exponent in front and then just solved for my x. Remember, example 1 was the first way to do that. Log of both sides, use your expansion to solve. The other way to do it is just take the log of 2 of both sides, okay? So if I take log base 2 of both sides,
Is it always gonna be 2?
so the reason I used a 2 here is because this was a 2, okay? Bases cancel out bases. So what happens on the left-hand side is this log base 2 and this exponential base 2 cancel each other out, and I only have the exponent left. Okay? And then what I can do is I can rewrite this guy using my change of base. So 3x is going to equal log 172 divided by log of 2. And to solve for x, I just divide by 3. So x is going to equal log 172 divided by log of 2 divided by 3. And I will get 2.475. So 2 methods. These are the same type of problems that we did in example 1. Example 1 just did log base 10 of both sides and expanded with the power rule. You can solve these either way. You can use like logs, or you can use log base 10 and expand. Either one, and you'll end up with the same answer. I did log base 7 of both sides. Log base 7 of both sides, that canceled out here and I just have 5x. Log base 7 of 3,000, change of base, log of 3,000 over log of 7, and then I divided both sides by 5. Here I did log base 10 of both sides and expanded. Log of both sides, expanded the 5x over, and then divided both sides by the 5 log base 7. So these two things in green are the same exact thing. And you end up with 0.8229 when you get it.
Can't be mad at it.
So just like we used a logarithm to cancel out an exponential base, we can use an exponential base to cancel out a logarithm. All right? So for this one, I have log of 3x plus 1 equals 5. And so what I'm going to do is I'm going to use the base of this log on both sides. What is the base of this log? When I don't see a base, what is it? 10. So I have log base 10, right? Which I don't necessarily have to write, but I'm just showing you. Log base 10 equals 5. Bases cancel out bases. So I am going to take 10 to this power and 10 to this power. On the left-hand side, my bases cancel each other out, and I'm left with just 3x plus 1. On the right-hand side, I have 10 to the 5th power. All right, 10 to the 5th. If I were to take out 10 to the 5th, I get 100,000, right? So I get 3x plus 1 equals 100,000. 10 to the 5th, 5 zeros there. I continue solving, subtract 1.
900.
Yes, pretty much. And then divide by my 3. X equals this guy right here. Looks like repeating, but it's not. That's my answer. So bases cancel out bases. Exponential bases cancel out log bases with the same base, and log bases cancel out exponents with the same base. All right. So the reason I did log base 2 over there was because it was an exponential base 2. The reason I did 10 to the power over here is because my log was base 10. All right. Whatever your base is, you're going to use that base to cancel it out. So go ahead and try check understanding 6. All right, so when you have something like this, the problem is you have multiple logs. So you don't want to start out with your base. The only time you want to cancel a base is if you have one log. And I have more than one log here. So I'm going to use my rules of condensing to get it down to one log, and then I'm going to use my base to cancel it out, all right? And so my rules of condensing say this 2 can go up here in the exponent position, right? So I have log of x squared minus log of 3. And then the next rule says that this subtraction, I can make those divisions. So I have log of x cubed over 3, 1 log. And then I'm going to have that equal to 2, right? I'm going to bring that 2 down. So now I have 1 log, and now I can use my base 10. This is a log base 10 because it's ununderstood, right? So I'm going to go 10 to this power and 10 to this power. On the left-hand side, the bases cancel each other out, so I just have x cubed over 3, and that equals 10 squared, which is 100, right? Multiply both sides by 3, that's squared. I don't know why I changed it to a cube. And I have x squared equals 300. My last step here is to take the square root of both sides. Now, I do have to consider the positive and negative root here because it is an x squared equals. So this is 300 is 3 times 100, which is 10 times 10, right? So a 10 can come out, a 3 can stay in. So x is going to equal the positive and negative 10 square root of 3. And I think they put it, yeah, in the calculator, positive and negative 17.32. All right, so I condensed using subtraction condenses with division, right? So this condenses to log of 6 divided by 3x. All right? Then I do a base 10 of both sides. On the left-hand side, it cancels. So I just have the 6 over 3x. On the right-hand side, 10 to the negative 2 is 1 over 10 squared. That's 1 over 100. Here's what I did. I reciprocated both sides, okay? So you can actually reduce this to 2 over x. I guess I should have done that first so you could see why I did that craziness. So 2 over x is how I reduce that. So I get, if I did that, reciprocate both sides. Reciprocate both sides. When what you're solving for is on bottom, you can just reciprocate it and make this x over 2 equals 100 over 1. And then you just multiply both sides by 2, and you get 200. Okay.
That's not what I did.